Hi class, how are you? It's Miss Sarah here. Wanted to talk to you a little bit about earthquakes. There's a bit of a thunderstorm going on in the background, and I'm still a bit tired, a bit full of cold, so I hope that I make some sense today. Also, quickly, just want to introduce you to Ishka, my cat. She's sat there, and she's helping me today. So, yeah, you've met her now. Okay, so earthquakes. What is an earthquake? What is an earthquake? What is an earthquake? I've made you a worksheet. I gave you this in class. I didn't have time to make this video last week, but now I have, hopefully, so you'll have it. So, what is an earthquake? An earthquake is a sudden and brief period of intense ground shaking, which is caused by a seismic wave. It's the seismic wave that you can feel. And this ground movement can be either vertical or horizontal. So vertical or horizontal. Vertical, horizontal. So the ground can either be shaking like this or like this. Okay? And the shaking, the seismic wave, is caused by two plates colliding. Two plates colliding. And often it's just when they get stuck on each other. So where do earthquakes occur? Where do they occur? You'll probably remember that they occur at destructive or conservative plate margins. You remember that destructive margins are when you have two plates that collide and one of them subducts and one of them breaks off a little bit in this really hot magma. So destructive plate margin, or conservative margin where nothing is broken and nothing is made. So usually side by side, either two different, like same direction, two different speeds, or opposite directions. So these two plate margins, destructive or conservative plate margins. Remember I told you to think about the ring of fire. The ring of fire. And the ring of fire is really pretty much around the outside of the Pacific Ocean. Pacific Ocean. This is known as the ring of fire, and it's where the majority of earthquakes occur. Right. So, how do earthquakes happen? They happen when two plates collide, either sideways or head-on. Sideways or head-on. They occur when one plate gets stuck or subducts. Remember that subduction is to go under. And when they get stuck, it causes strain. And the surrounding rocks become strained and under pressure. Tension builds, and when the tension is released, it produces a shock wave. And it's this shock wave that we call in science, in geography, a seismic wave. So it's all to do with the tension, the pressure being released. And you can think about this a little bit like having an arm wrestling competition. If I was having an arm wrestling competition with you now, if we are both winning, we're holding each other's hand, we're both winning, then neither of us moves either way. We're kind of stuck. But if one of us is stronger than the other, we either end up going forward or backwards. As your arm hits the table, it bangs on the table, but the bang kind of like expands out. It makes a noise that goes out, a seismic wave, and it's pretty much the same thing that's happening with these two plates when these two plates are stuck on each other. When they hit each other and they stuck. And the focus is the place where the earthquake starts. The place where the earthquake starts. And the seismic wave starts here and it spreads outwards, rather like when you throw a stone onto a pond, onto a very flat pond. You throw the stone and the place where the rock first hits It's almost like that is the focus, and then you get little ripples that go out. Okay, so you can think about it if it helps you to remember. It's like the point where the stone lands on the water, but obviously it's not water and it's not something landing. It's like from this pressure that's escaping. Okay. How do we measure earthquakes? There are two ways in which we can measure earthquakes, and they measure different things. The first one is on the Richter scale, and this measures energy released from an earthquake. It uses a seismometer, and I told you that the word mometer is really about measuring. And what's it measuring? Seismic waves. It's measuring the shock wave, and it measures this on a seismograph. And I showed you a picture of a seismograph and a seismometer, and it's really like, if there's nothing, if the ground is not shaking, if you had a record player with a little needle on it, the record would play really nice, absolutely straight. But if you jump that, if the earth jumps, if there's movement, then obviously the needle on the record will jump, so it sounds different. So you can imagine it a little bit like a record player. When there's no movement of the earth, the needle is completely flat, but when it jumps, it's like a pen on the end, and then you get little spikes. And the size of the spike is related to the size of the earthquake, the earth tremor. Okay, so it's a logarithmic scale. It goes on forever. There is no higher limit. The measure is usually 10 times stronger than, for example, like a measure of 5 is 10 times stronger than a measure of 4, and it's a logarithm. Most of our earthquakes, the most serious of our earthquakes, are in the range of Richter scale 4 to 9. 4 until 9. And the second kind of way that we measure earthquakes is called Mercali Scale. Mercali Scale. But this measures what people experience and the amount of damage done. So it's a little bit more subjective, I suppose. So, for example, if there was on a Mercali scale on the range of 2, if it was 2, then you wouldn't feel anything. Maybe the seismograph would show a little spike, so something is noted, but no one felt anything. No one even noticed it. So that would be a scale of 2. And the scale goes up to 10 to 12. On a scale of 12, you have buildings collapsing, houses collapsing, churches, schools, everything collapsing. You'll have landslides, and you'll have the ground cracking. So it's quite a big jump from 2 to 12. So that shows you how extreme the earthquake is, how big the tremor is. The effects of earthquakes. What are the effects of earthquakes? Well, what happens is the shock waves actually, they send this like massive vibration through the rock, and this vibration ends up kind of liquefying. It turns the rock to liquid, like a sticky treacly kind of a thing. The soft rocks get like liquefied, and then they behave like liquid. So you'll see them almost flowing like a river. And it's because of this that the buildings collapse. So really you can think that it's not earthquakes that kill people, but the buildings themselves that kill people. Because if you can imagine having a building on top of, custard or treacle, and it's all washing away, then your building has nothing to stand on. It has no strong foundations anymore. So it just kind of washes away. The ground disappears underneath. Another really big effect of earthquakes is tsunamis. And we've seen, like on the media in Japan and India, the really big devastating effects that tsunamis have. And tsunamis are caused by earthquakes. So you can remember that. The epicenter. Epi means around. It's Latin for around. And center is the middle. So epicenter, around the middle. Epicenter. The epicenter is right above the focus. Remember, I told you that the focus is the place where the earthquake starts. Place where the earthquake starts. The place where the seismic wave starts to spread outwards. The center of this. And the epicenter is right above the focus. So is the epicenter. So right above it here is the epicenter. Focus, epicenter. The epicenter is right above the focus, but it's on top of the Earth's surface. And the seismic wave is the strongest here, and it causes the most damage here. I did draw you a little picture, a little diagram, if you can see here. Let me see if I can show you. So here you have your seismic waves in red, here, seismic waves. We've got the focus down here. Let's see if I can show you here. And we've got the epicenter. So you can see focus and epicenter. Alright, so bit of a rush video, not making much sense today, but I hope that it helps you a little bit. Alright, I'll catch up with you in class. Alright, see you later. Bye bye.